Check this.
Welcome back. Today we're going to do part 2 of properties of logarithms. Let's go on to the 2 new things that we're doing today. So the third property of logarithms is the quotient property of logarithms. Okay, we had the base property, we had the product property, product meaning multiplication, and now we have the quotient property, quotient meaning division. All right, and the idea here is simple. When you divide, all right, for the product is when you multiply in here, you add over here. Well, now when you divide over here, you subtract over here. And that makes sense because when you think about it, if you divide 2 powers of x, let's say you have x to the 5th divided by x to the 3rd. What do you do with the powers? You subtract them, right? 5 minus 3. So division here leads to a subtraction situation. 5 minus 3. Okay, which in this case is 5 to the 2. Sorry, x to the 2. Okay, so that's the same logic here. If you have log of any base, we'll just call it b for now, okay, of, I don't know, 5 over 7, that's the same as log base b of 5 minus log base b of 7, okay? The only difference is that this is division instead of multiplication, and this is minus instead of plus. Otherwise, it works exactly the same way. This b is bothering me. Let me make it look like a b instead of a weird 6. So anyway, you can also go both ways. You can, if you have subtraction of 2 logarithms, you can combine them going the other way. And we're going to have to do that in the next example here. So if you can, it goes both ways is the point. All right. It's not just if you have division, you get subtraction. If you have subtraction, you can go back to division as well. All right. Okay. So that's the explanation of the property. Let's go ahead and do an example with it, or 2 examples actually. Here's the first example. We're going to solve this equation here. Now you notice I haven't written any bases on these logs. If you don't write a base, the base is 10. It's implied. Okay, it's called a common log. All right. So we have a log base 10 of this thing minus a log base 10 of this thing equals this log here. And what we learned yesterday was you cannot just cancel these out and write 2x plus 2, I guess minus 2 equals 14. That would not work at all. Okay? You have to use one of the properties. So what's the property here? Well, we have subtraction. And subtraction means that we can use the quotient property right up here. So we can rewrite this. Let me get rid of this here. It's in my way. We can rewrite this thing here, okay, as a single log, where the first thing before the minus is on top, and the second thing after the minus is on the bottom. Okay? And that would actually simplify, because if you heart this, right, you'll see that this becomes 2x over 2, which is just x, and negative 2 over 2 becomes negative 1. Okay, so you can simplify it that way. And then the other side is just simply log 14. And now, once again, we don't write it, but these are both base 10. So the bases match, and if the bases match, drop the logs. And you get x minus 1 equals 14. Add 1 to both sides, and you're done. X equals 15. And of course, check your answer. If you put a 15 in here, and you put a 15, well, you can't put a 15 in here, but if you put a 15 in here, you get 30 plus 2, which is 32. Yes, 32 you can take the log of. It's not negative and it's not 0. So it works in this log is fine, and this log is fine. So yeah, that's going to work. Okay, we know it doesn't violate the domain of the logarithms. Whether or not 15 is the correct answer is a whole different story, but if it is 15, it doesn't violate the domains, so you're cool. You have to check that. Okay? All right, this next one is a combination of product property and quotient property. Because check this out, we have adding and subtracting. We have both. So what do? Well, if you look at just these two, right, this is log of x times y, right? That's literally the definition right there. Log xy equals log x plus log y. For the product property, that is the definition. But if you look at the last two, this is a minus, so this is log y on top and 2z on the bottom, right? So how do you handle this? What do you do? Well, the answer is start from left to right, okay? Just do one thing at a time. So, with PEMDAS, it's multiplication before addition and subtraction, but there's no multiplication here. This is just adding and subtracting. And adding and subtracting are on the same level in PEMDAS. So it's, like parentheses first, then exponents, then it's multiply and divide on the same level, and then it's add and subtract on the same level for PEMDAS. So since it's just adding and subtracting, we can do them in either order. We can subtract first or add first, it doesn't matter. So let's just go from left to right, and we'll just do the first two first. And once we get an answer, then we'll subtract the 2z, okay? So this part, like we said a second ago, this part right here is log of xy. And now this is minus log of 2z, okay? And now we have a single log minus a single log, and we can use the quotient property. So now this becomes log of a fraction where the top is the thing on the left, which is xy, and the bottom is the thing on the right, which is the 2z. And that's it, we're done. That's our answer. Okay? So this is once again called combining logarithms. You can do it with the product property, and you can also do it with the quotient property. And here we actually did both. Last property of logarithms. Okay, just to recap, we've done the base property yesterday. We did the product property yesterday. Today we've done the quotient property, and now finally the power property of logarithm. And this is actually the one that brings the x down from the tower. Okay, if you have a logarithm of any base, okay, and the logarithm is of an exponential that has a power, like x to the 5th power, for instance, okay, this is exactly the same as what you would get if you took that power to the front like this and got 5 log any base x. Okay, so if you have a logarithm, you're allowed to do that. This is the power property of logarithms. All right. It reflects the property of exponents, but we don't have to get into that right now. So this is the big one. This is the one that helps you, get exponents down. So I keep referring to this example of 10 to the x equals 15 from last time. And I said, is there a way to bring down that x from the tower, as it were, right? Well, you can't do it while it's an exponential, but what if you took the log of both sides, right? Take the log, and you can do that. You could take the log of this side and also take the log of this side. Now suddenly both of them are logarithms, and now you can use the power property of logarithms to take this and bring them down. And now you have x log 10 equals log 15. And you might say, well, that looks more complicated. Yeah, but now you can get the x by itself. You can divide the side by log 10. Gone. Divide this side by log 10. And what you get is x equals log 15 over log 10. Now, I didn't write any subscript here. So this is actually any log I want it to be. So you can actually use log base 10, which is the common log. And your calculator will do these. So just take your calculator, find log of 15 and divide it by log of 10, and you'll get your answer. Okay, so now suddenly we have a way to solve for x that doesn't involve guessing and checking, and is very, very direct and simple. Okay, the power property of logs. So to recap this one, okay, anytime you have, I'll write this, even if you have a function, like y equals log base 5 of x to the 25, for instance. Okay? You are allowed to take that power, just because it's a log. That's the only requirement. Any base, doesn't matter. As long as this is a log, you're allowed to take the power that's up here and stick it over here. So you get y equals 25 log base 5 of x. You get the power off of the x. Okay? Or what if this is y equals log base 7 of 3 to the x, for instance. Now here, can you get the x to come down? Actually, let me not use a y because that's not solid. Let's do something that we can actually solve. Okay, so I'll make that a 10 right here, for instance. Well, you're allowed to take this x and bring it down. Now you have the x down here where we can get to them. And we have that. Okay. And if you want, you can divide both sides by log base 7 of 3. And I know the calculator won't do that, but we're going to learn a trick later on in the chapter where we can actually do this with a calculator. So eventually you'll all be able to do these things with a calculator, but the point right now is not to use a calculator for these. All right, that's the power property of logs. And that's the last one. So let's just do some examples here. So the first one is one of those, like the homework last night, where you are given the value of a certain logarithm, right? So log base 2 of 5 is this decimal right here. And they want you to approximate log base 2 of 25. Okay? So the game was to break down this number here into factors that either involve what they give you, which is 5, or what the base is, which is 2. So what we want to do is find factors of 25 that are either 5 or 2 and use those to factor 25. Well, 25 is easy. 25 is just 5 times 5. Okay, it's like the most common thing that you think of with a square root, besides 3 times 3 maybe. So yeah, this log base 2 of 25 can very easily be written as log base 2 of 5 times 5. And now we can use the product property to go, all right, this is log base 2 of 5 plus log base 2 of 5. Okay? And that means that this is 2.32 and this is 2.32 and that's 4.64 and we're done. But wait, we could have also done this a different way, maybe a quicker way. We could have realized, this is an alternate way to have done the same problem, that log base 2 of 25 is actually log base 2 of 5 squared. And then you can use the power property of logarithms to bring that 2 and stick it out here as a multiplier, a constant multiplier. So this becomes 2 times log base 2 of 5. That means this is 2 times 2.32, which is also 4.64. So you might say, hey, well, I'm more used to the first one because I learned it yesterday. But understand, there's another way, a faster way, in a matter of speaking, to do this just by bringing down the power. Okay? And that's an example of how you can use the product. I keep saying the product. You can use the power property of logarithms to get things done. Okay? Because sometimes this here would be more tedious than this here. In this case, they're about the same. All right, next example. Solve for x, meaning get the x by itself. Okay, so there's a couple of ways to look at this. There's actually one really easy way to look at this, but I'm going to do it the slightly harder way just so you can see how to do this with the power property. With the power property, our goal is to get the x to come down from the tower, from where it's stuck up here, right? So what we're going to do is use the power property of logarithms, which is if you have a power and this is a log, any base, it doesn't matter, you're allowed to take that power and make it a coefficient out here. So now this becomes x log base 4 of 4 equals 10. Okay? And we learned yesterday and a little bit today that if these two numbers match, then whatever the power is up here is going to be the value of the entire logarithm. Well, there's no power here, so it must be a 1, right? So this whole thing right here is a 1 because this cancels out. Okay? So this becomes x times 1, which is just x equals 10, and we're done. Now, if you're paying a lot of attention, you might have said, yeah, well, don't these just cancel out? So yeah, you wouldn't be wrong. Had you said, well, log base 4 of 4 to the x equals 10, this thing is one of those where this cancels out and you just get x equals 10. That's the other way you could have done it. But once again, the power property here, you know, if this were a more difficult question, the power property would be a lot more valuable here. Here you can go either way, but I just want to show you it in action with a simple example. Okay, now the last example. This one is a solve for x type of example here. And you notice at this time we have subtraction. So we're not going to be using the product property. We're going to be using the quotient property. And once again, we can't do anything while there's two logs here. We need to get it down to a single log. So how do you take a log minus a log and combine it into a single log? Well, you use the quotient property in reverse. The quotient property, once again, was if you have log of a quotient, x divided by y, that you could split it up into log of the top one minus log of the bottom one. And it works both ways. So in this case, the top one would be x squared minus 9x, and the bottom expression would be x. So this is the same as log of a base 6 of a fraction, and the top of that fraction would be x squared minus 9x, and the bottom would be x. And that's a 2. Let's simplify this over here. So this is going to be log base 6. Now we can split the fraction, in other words, the Hart method here, and that would give us an x right there, right? And this would give us a negative 9, right? And now we have that. Now you cannot drop the log here because you would have to have logs on both sides. So if you can't drop the log, what you need to do is turn this into an exponential. So start with the base. This to the power of this equals this. So that means 6 to the power of 2 equals x minus 9. Well, 6 squared is 36. And we want to get the x by itself. All right, so we can add 9 to both sides. And we get 45 equals x. Always have your answer with the variable on the left, so we'll flip it around. X equals 45. And there you go. Now let's check our answer to make sure it's valid. If you plug a 45 in here, does it cause a problem? No, because log of positive 45 is fine as long as it's not 0 or negative. And if you plug a 45 in here and a 45 in here, well, this might be a problem. Let's see. Here is going to be 45 squared, which is 2025, minus 9 times 45, which is less than 2045. So a bigger number minus a smaller number will be positive, so this is going to be fine. Okay, if you don't believe me, check it with the calculator. Okay, so yep, this is good. And so we're done.